back to the second part in this series of balancing chemical equations, and congratulations to you. You've reached the medium level difficulty of the question. So we did an easy question in the previous one, which was balancing a carbon, hydrogen, oxygen related equation, and now we are moving to a medium difficulty, which I consider, which is regarding different elements. So let's get started. We're going to use the same method described, and if you have not watched that video yet, go and watch it. But I'll briefly describe what we do. This is named as the LHS, or the left-hand side of the equation, and this is known as the RHS, or the right-hand side of the equation. And what we're trying to do is trying to fill the coefficients so that this equation is balanced. How will we balance this sort of equation? Let's get started. First, as I always said, we do oxygen last, and let's focus on the other elements. Since we don't have hydrogen this time, which I said was important last time, let's consider our next first element, which we consider is a metal over here, which is aluminum. Okay, aluminum, I'm sorry, whatever you guys like to call it. Yes, here we have 2 times 1 because the subscript times the coefficient, which is 2Al, which I will be calling it Al. And here we have 1 times 1. If there's nothing, we consider it to be an automatic 1 in chemistry. So 1 times 1, which is 1 aluminum. So what can I do to the smaller one on the side to achieve to the bigger one? Well, that is simple. Multiply the smaller one by 2. Let's do that. Let's multiply the smaller one by 2, and I'm going to be placing a placeholder of a 2 in front of the aluminum, or the Al. Alright, that was pretty good. Now let's move on to the next chemical, which we have here, Fe. Fe is the symbol for iron. Okay, now let's see. On the LHS, we have 1 times 1, which is 1 iron, 1 atom iron, and here we have 3 times 1, which is 3 iron. What can I do to the small one to achieve the big one? Well, this one is quite simple. You multiply by 3. Now, so far, you might be thinking that this is quite easy. Why do you consider it to be difficult level? Well, we're getting there. We're getting to the oxygens. As I said, they're always the troublemakers. Anyways, I will be removing this section so that we can continue easily. Alright. Oh, I did not mean to do that. Let me quickly remove it again. Alright. Now let's move on to the oxygen. This is wonderful. Here we have 3 oxygen, and here we have 4 oxygen. Now this might be simple. Oh, come on. Let's just multiply this by, what can we multiply this by? This is where comes the importance of coefficients. Now, if you notice carefully over here, if I add any coefficient, like let's say 2, the quantity of aluminum also does change, which will impact the amount of aluminum we need to multiply over here. Hence, this is very important, and oxygen are always the troublemakers. In these sort of equations, it is important that we address oxygen first. This is why I was trying to show you guys the importance of doing oxygen and why it's really difficult. In these sort of equations, it is actually best if we do oxygen first so that we don't have to keep going back and changing our answers. So let's go in with this with a fresh trial. Now you know that oxygen and hydrogen are the ones that you should do first because they're the big troublemakers. Let's move on to the oxygen first. 3 here, 4 here. Let's look at the smaller one. Can I multiply the smaller one? Here it would be beneficial because here if I multiply anything, it actually wouldn't matter, but I suggest let's go and start off with doing aluminum here. As we saw over here, there's 4 oxygen, and what is the smallest multiple of 4 and 3? In this case, it would be 12. So what I can just do now is just multiply this by 4. Because, I can just multiply this by 4. Now we have 12 oxygen on the left hand side. So let's try to get the same amount on the right hand side. So here all we're just going to do is going to get in and put a 3. Now we have reached the LHS, or the lowest common LHS, I mean the LCM, the lowest common multiple between the both. If you do not know what that is, please go watch videos or ask me and I can upload a video on finding LCM to help you guys know which coefficient goes in front. So here there is a 4 and a 3, so now we have 12 oxygen, so it satisfies our thing. We got rid of the hard and annoying element first. Now let's look at the amount of aluminum here. There is 4 times 2, which is 4 times 2, which is 8 aluminum here. That means we need a number to balance here. Since this is 1, what can I multiply with 8? What can I multiply with 1 to get 8? The answer is simple, 8. So we put a placeholder of 8 in front of the aluminum, and now let's move on to our last element, which is iron. I might be going a little fast, and if you guys do not understand, drop any comments and I can just go over this again. Anyways, here now, since we've set a coefficient here to the oxygen in the placeholder, let's try to solve this first. Placeholders, let's get those rid of. So we have 3 times the smaller subscript, which is also 3. So we have 9 iron on the right hand side. And we want the same on the left hand side. So what can I multiply with 1 to get 9? The answer is simple, 9. I multiply 1 with 9 to get 9. So the answer for this placeholder would be 9. And this is how I've come to this conclusion. Let me quickly erase all the irrelevant stuff so that I can quickly explain why I have chosen this method. I think I might have erased half of my work. Just hold on, please. I'll put a 4 here and an 8 here. All right. Let's follow my checking method, and that would help us to understand why we're here. Let's break it down and write down the elements we have. We have aluminum, iron, and oxygen. Aluminum, iron, and oxygen. Here we have 8 aluminum. Here we also have 8 aluminum. Here we have 9 iron, and here we have 3 times 3, 9 iron. And here we have 4 times 3, 12 oxygen, and here we have 3 times 4, 12 oxygen. So yes, our equation is balanced in the right way, and this is the balanced equation. Let me just quickly explain once more, as I said I would, to debrief it. What we do first in these tricky questions is to solve oxygen or hydrogen first, because they are the most difficult ones. Here we had no hydrogen, so we went straight to the oxygen. So here we start off with the right hand side. What is the common multiple between 3 and 4? That is a whole number. That is 12. And to get 12, you have to multiply 3 by 4 to get 12. So that's why we put a 4 here, and consequently we have to put a 3 here to get 12. That was set. After that, we have to move on to any metal you could actually really do now after, but I decided to go with following order, aluminum. So I multiply 4 times the subscript 2, which is 8, and here the subscript was 1. So what do I multiply 1 with to get 8? That is 8, and that is how this placeholder came. That is how we get 8 aluminum. Now let's move on to iron. Since we had a placeholder here, it is important we address this before going to the other one. 3 times 3, which is 9 iron. So we knew here that we have 9 iron, and now what can we multiply? This was none, it had just 1. So what can we multiply the smaller one, which is 1, with to get 9? The answer is 9, and that's how we got 9 here. And this is how we have our balanced equation for this chemical reaction. Alright, I hope you understand. This was the medium difficulty, and look at my next video for the harder difficulty question. Alright, thank you.